Okay, let's take a look at some of these formulas. So, we're going to remember that we are going to be using special triangles, the same special triangles that we did back in grade 11. Remembering now, pi is equal to 180, so we're going to be filling out special triangles based on radians. At the top right, we're going to be using arc length and sector area formulas to find out information about circles. We're going to be using the ASTC realm. We're going to have reference angles, and we're going to have arrows from the principal axis to the terminal arm called the angles in standard position. We're still going to have our SOHCAHTOA domain, and we actually have some new definitions, cosecant, secant, and cotan, which are the reciprocals of their respective aboves. And we have, if we need to find an angle, we're always going to inverse the positive. In the top right, I'm going to overline in big blue, only inverse positives. That always gives you the reference angle. And we have a new mnemonic device, CHO. Some teachers introduce something called Sir-Kixertix. It's just a little bit odd. CHO is just as odd as well. So now we also are going to be putting things in graphs, talking about quadrants and finding different angles off to the right with those different formulas, but logic is going to be your best friend there. And we're going to talk about all sorts of different angles, such as coterminal angles and general solutions. And we're going to be talking about period. And remember, the period for sine and cosine is 2 pi over b, and the period for tan is pi over b, or we might be doing it in degrees. We're also going to be using the unit circle and our new definitions of sine, cos, and tan in big red. Sine theta is the y value of the unit circle. Cosine theta is the x value of the unit circle. Tan theta is the slope of the unit circle. So we're also going to be taking a look at the sine graph and the cosine graph and their reflections, and our general form with all of our different letters that represent the same letters from chapter 1 and what they do with respect to horizontal compressions, expansions. That's on the next chapter 5. And we might be graphing tan. So let's take a look at a trig checklist. We have to be very good at converting back and forth between degrees and radians, making sure you're careful as to which mode your calculator is. Again, remembering we can find arc length and sector area with these formulas. Always making sure you logic and checking your answer. Off to the right, taking a look at some very important words that we're going to be using. Angles, ratios, triangles, the unit circle, algebra, period, factoring, non-permissible values, general solutions, arc and area, and angular velocity. We should be able to do each and every one of those. Back to the left, we have special triangles in the ASTC graph with the 4 quadrants and the formula for the unit circle, a circle with a radius of 1. We have a concept from grade 8, similar triangles. We have to use that concept all the time to compare similar triangles of different sizes. We have to remember from grade 11, we have to be able to rationalize, either if necessary, to more easily recognize a special triangle, or if the teacher requires it. We're going to see all of these different types of angles. So we're going to have theta. We're going to have theta in standard position. We're going to have a principal angle. We're going to have a reference angle. We're going to have a coterminal angle and a general angle. Theta and a general angle. So we have positive angles that go counterclockwise from the principal positive x-axis, and we have negative angles which will go clockwise from the positive x-axis. We have theta STP, which was our arrows. We have our reference angle, which is the small little angle in the triangle that is always between 0 and 90. We have coterminal angles, which are angles in standard position, plus or minus 2 pi. And we have our general solution, which is our angles that we got in standard position, plus or minus the period times n. The period will change, but most commonly 2 pi over 2 pi n. And the principal angle is the angle in standard position that's between 0 and 360, not as common. Off to the right, remember we have SOHCAHTOA and cosecant, secant, and cotan, and our mnemonic device, CHO. We have to remember that sine and cosine always need to be between -1 and 1. We can't have an opposite or an adjacent bigger than the hypotenuse, so the fraction must be a decimal between -1 and 1. We're going to be talking a lot about domain. So we're usually going to go from 0 to 360 or 0 to 2 pi, but lots of the times they change that, and we have to be very careful as to where we put the arrows. We go over that later in the chapter. We're going to be solving equations, and when the funny thing is 2x, we make m that, and if the funny looking thing is sine x, we make m that. Then we do grade 11 steps, and then we substitute what we made m back in at the end. Within respect to the ASTC graph, we're always going to mark 0, and always mark 2 pi, and we're always going to change pi and 2 pi to have a denominator that we are working with. We're also going to take a look at a little bit of a linear velocity depending on the school. So, just a big summary. This sheet is a big summary of all the things that we're going to do, and I'm not going to go over this full sheet. I'm just going to go over it very fast. Sometimes we're given an expression, and we answer the question with a fraction using the ASTC graph, and all of our definitions off to the right. Sometimes we get an equation where we have 2 triangles within the ASTC graph. 2 triangles. Where above we only had 1 because it was an expression and they told us the angle. But this time they gave us a fraction, and using the definitions off to the right, we can label the triangles and then eventually put our arrows in, as I should have in the last one, and give what those arrows are worth using special triangles. Sometimes we use one special triangle, sometimes we use the other. The next example, sine theta is equal to 0. Well, our definition states that sine is the y value of the unit circle, so we draw the unit circle, and then we answer the question. So my arrows are 0, pi, and 2 pi. But if you notice, from the domain above, we don't include 2 pi, so we reject it. Then a general solution, all of the answers in the future. We'll go over that later in the notes. Then, for example, we may have a fraction equal to an equation that's equal to a fraction that we don't have special triangles or unitary angles. So first of all, we're going to use the definition of cotan. We're going to switch it over to a question now like tan, like we've done before with cosecant to be sine above. And then we're going to inverse that calculation. Now, I'm going to put a big blue arrow down to the bottom left to the inverse calculation. Notice the fraction is negative, but I still inverse the positive value because that always gives me the reference angle, and then I always just put my arrows in. Now check out this interesting domain I'm going to underline in blue. That tells us where we put our arrows. So in big blue in the graph off to the right, I put my arrows from 0 to 2 pi, as they've said, and in big red, I put my arrow back to negative pi, and then I give 3 answers. So again, from our checklist, be really, really careful with domain changes.